My name is Thomas Taylor, and I'm with Bentley Civil in Huntsville, Alabama. And my primary job responsibility here at Bentley Civil is in certification. Those of you may have already met me. I've done a number of classes at different conferences, including the most recent one out in Denver. Today's lecture we're going to cover version 8.7, superelevation. I'm going to spend some time discussing 8.7 versus the previous versions of 8.5 and prior, and I'm going to take you through the different methods that to accomplish superelevation within the new InRoads roadway designer. So let's cover today's agenda. We're going to cover the superelevation interface within the roadway designer. I'm going to explain all the different aspects to the roadway designer and its interface. We're going to also cover the rate calculator, and that is the way we achieve design speeds and the actual superelevation rates. We're also going to cover the AASHTO method wizard for achieving superelevation. We're going to cover the alternate method of the table method wizard. We'll also be covering defining rollover locks within the superelevation in the designer. We'll discuss aspects for importing superelevation from previous versions. And then I'm going to take you through a workflow for a 4-lane divided superelevation and how to handle that. We're going to cover it with a planar superelevation between the median and also creating a median super with the same rate as the left and right side travelways. Then we will discuss rollover locks and how they can be handled within the template. And then we will conclude with how to edit curve set stations within the superelevation portion of the designer. So let's get started with the superelevation interface within the designer. As you can see on this slide, the designer has 4 views when you're within superelevation. You have the plan view, the profile view, the cross-section view, and the super view. Let me go ahead and swap over to InRoads, and we can take a look at that live. To access the roadway designer, we first click on the modeler portion of the InRoads toolbar, and we go to roadway designer. When you bring up the roadway designer, you will initially be in the standard 3-port view, which contains a plan view, a profile view, and a cross-section view. To access the superelevation portion of the designer, select the Display Superelevation button located in the lower right-hand corner of the roadway designer dialog box. As you can see from the previous slide I showed you in the PowerPoint presentation, you have the plan view, a profile view, a cross-section view, and a superelevation diagram view. Note within the superelevation diagram view, all your key points are listed for your curves. We provide options to permit curve set IDs to be displayed, so when you are windowed in very close in the plan, profile, or superelevation diagram view, you have an idea of where you are along the alignment. I'm going to go ahead and turn that on. Click OK and dismiss that dialog. And as you can see, we have 3 curves on this alignment. Let me give you a little overview of the superelevation diagram and what it does. When you create superelevation in InRoads version 8.7, you are creating a series of control lines that contain station and cross slope. And they are automatically assigned to points on a template, and when coupled with a reference point or pivot point, as in previous versions, it achieves superelevation relative to the pivot point. Also, it's good to note that they override normal point constraints that are stored in the template. To access superelevation and create superelevation within InRoads version 8.7 inside of the Roadway Designer, there are two methods. Most commonly used by myself and probably others is the right-click method. If you right-click in the superelevation diagram view portion of the window of the dialog, you will access a menu. And as with everything within the Roadway Designer itself, the menus are context sensitive. What does that mean? That means that depending on where you are and which view you're in and whether or not you're hovering over an element within a window, you're going to get different menu options. As you can see within this right-click menu in a blank superelevation diagram, you're permitted a number of options. The one we're going to use initially is we're going to create superelevation using a wizard, which is the second option in the menu, and we're going to use the AASHTO method. But before I do that, what I'd like to show you is that there is an alternate means to access it, and that is in the main toolbar pull down at the top of the Roadway Designer. If I click on that, you will notice that we also have the Create Superelevation Wizard option. So at this point, I'm going to go ahead and I am going to create superelevation for this particular roadway using the AASHTO method. So I select Create Superelevation Wizard, and then I select AASHTO. This is the step one of the AASHTO wizard. Everyone who is in the United States will probably understand all of the terminology within this dialog. We have delta G, percent of runoff on tangent, and spiral to tangent point, as well as the nonlinear curve length. And what that does is that provides the rounding at the PIs of the super diagram. Everyone should be familiar with that because that comes over from the old version of the product. Now, prior to running the AASHTO wizard, we have to compute superelevation. Notice in my horizontal curve sets down here, I have my curve ID 1, 2, and 3, which correspond to the curves in my plan profile and diagram views. Gives me my stations, my cardinal stations, but also notice now I have no superelevation rates. Well, in order to compute superelevation rates, we will need to invoke the superelevation rate calculator. To access the rate calculator, I will click on the rate calculator button located here on screen, or alternatively, you can access the rate calculator from within the geometry menu on the InRoads Explorer. This is the superelevation rate calculator. It provides the means to compute superelevation and enter a design speed for a particular roadway. When we compute the rates within the superelevation rate calculator, you now have the option to individually enter design speeds and compute design speeds for each curve set independently. Now this is a change from 8.5, where you are only able to enter one design speed and compute a rate throughout. Well, I believe this is very useful because now if you have, for example, a deceleration ramp, you can have your initial curve set at 55 miles an hour, for example, and then the second curve as you approach the crossing road, you can compute for 30 miles an hour. Let's go ahead and let's compute the rates for this particular alignment. I'm going to multi-select all the curves within this dialog by holding the Shift key down and selecting all the curves. At this point, access the actual computational portion of the rate calculator, I'll select Edit. Now within the rate calculation editor, we provide a number of methods, and those of you who are familiar with the InRoads product will probably recognize all of these methods. These are all standard methods that we've used in the past. They're using the same computational engine that they had before, and so I feel like that you should be able to easily understand where the values are coming from. Also notice that there is a preference button on this particular dialog, so we can store the values you need and the method you choose to use at any point by recalling a preference. I'm going to my preferences now, and I'm going to select the 40 miles per hour preference and load it. Click Close to dismiss the dialog, and notice that it saved all the values that were in that preference for computing the rates based on the speed. At this point, if I click OK, you will notice that it has computed the rates based on the design speed for these particular curves. Also notice that the super elevation for normal crown and reverse crown are reflected as NC and RC. Now, to commit these rates and this design speed to the design, we will need to hit Apply. Once we click Apply, the design speed and the super elevation rate are written to the alignment and stored there. Now the data structure has changed a little bit between versions pre-8.5 and 8.7. Now with super elevation, we no longer store the stations and rollovers and all of that information in the ALG data structure or geometry data structure. Now it is completely and totally stored only the rates and the speed in the ALG, and the stations and cross slopes are stored in the InRoads Roadway Designer file. Now that I've committed that, I want to go ahead and load a preference for 40 miles per hour within the AASHTO wizard, and notice that my maximum delta G has changed to reflect the delta G for the design speed. Also notice that it has automatically toggled the button for percent of runoff on tangent to a percent of total on tangent. Now by selecting Next, I can go to step 2 within the wizard, and I can add my first section. By selecting the Add button, this invokes the Add Superelevation Section dialog. At this point, I can key in a name for the superelevation section, and I need to identify the crown point, the left range point, and the right range point. Well, with version 8.7, we provide multiple means to do this. I prefer to use the Select button and go out into the cross-section window and identify the crown point. I'll repeat this process for the left range point and the right range point. Notice how it automatically populates the fields with the points I have selected. In this particular scenario, I have selected the center line for the crown point. Left range point is the left edge of pavement, and right range point is the right edge of pavement. Also notice that there is a pivot direction, and it provides multiple methods of pivoting based on the crown and range points. We'll get into that a little bit more later. Also notice you can limit the stations for a particular section. This is particularly useful if you have, for example, one curve on a roadway that's a two-lane portion of the roadway, so you want to compute differently for the 2-lane versus the 4-lane sections. Notice once I've clicked OK, it has now populated the sections information with the information entered by using the add. I can also go back and edit or delete those. And it also provides superelevation sections for each curve. Notice how the normal crown curve, which is the first curve on this alignment, is 0, which makes sense. Also notice that it has computed a width, and from the width, from the crown to the range point, to compute the entering and the exiting transition length. At this point, we can go in and manually edit the superelevation curve information, and we can make any adjustments necessary. Notice on this particular data set that I have a distance of 31 feet, but note that the maximum number of lanes is set to 1. Some of you are probably curious as to why that is, and the reason for that is that my typical section only has one segment from the center line to the edge of pavement. And I am using something called parametric design to establish my lane widths as well as independent horizontal controls. If you want to make adjustments at this point, we permit a manual key in to that value, and it will automatically update any of the values that require updating based on the number of lanes. I'm going to go ahead and I'm going to apply that change and close that dialog, which will bring me back to the wizard. Now I'm going to click Next, and on the last dialog of this wizard, what I'd like you to note is that we can round to the nearest station value. Also notice that it calculates the initial slope automatically. So now I'm going to click Finish, and it is simple as that. We now have created superelevation throughout this particular roadway. If I click back to my normal view, you can see that we have superelevation. Now let me take you through the table method. I'm going to flip over to a different corridor, go back into my display superelevation dialog, fit my views, and I'm going to access the wizard for the table method. With the table method, it's going to use our standard .sup files to derive the data and look up the data from that ASCII text file. Once again, we provide a preference that we can load. I'm going to browse for the superelevation file. At this point, I come up with a dialog requesting a design speed. Well, the design speed is 55 miles an hour. That will put that value back on the ALG. I want to use the percent of total on tangent, and also I want my transition lengths to be the total transition, and I want it to interpolate the table values. Now a change between 8.5 and 8.7 is now we interpolate all the values. Prior to 8.7, we only would interpolate the rates but use the next longest length. Well, we no longer do that. Based on customer requests, now when we interpolate table values, we interpolate the super transition length as well as the rate. We'll click Next. Similar interface. We're going to add a section. I'm going to provide a name for that section. Identify a crown point, a left range, a right range, pivot direction from crown, and I'm going to tell it that I'm going to use the 4-lane column within the ASCII file. Also notice that we provide a runoff length multiplication factor. Because this is a 5-lane roadway, I'm going to key in 1.25. I'm going to click OK to accept that. And adjustments are made to the super transition length based on that lane multiplication width factor. We will select Next and Finish. And it's that simple to go in and create super elevation using the table method. If I change my display properties so I can fit the cross-sectional view in the window, you'll notice that I have 5.3 as my super elevation rate through this curve. But I also want you to notice that my shoulder on the high side is still at 4%, which is in violation of rollover values, and my low side is also still at 4%. Well, I'm going to go ahead and I'm going to achieve rollover lock by using the Apply Shoulder Rollover Lock command. After I right-click and select Apply Shoulder Rollover Lock, it invokes the Apply Shoulder Rollover Lock dialog. The Apply Shoulder Rollover Lock dialog will automatically populate any points located outside the range points that are not super elevated. And as you can see in this particular data set, the shoulder point is left outside shoulder, and it will automatically populate a name for the control line. And all we have to do is simply key in a high side difference, which I'm going to use 4% in this case, and a low side difference, which I want to leave at 0. Once I select Apply, it is going to look beyond that point for the next available point on that side. As you can see, I have a left outside shoulder unpaved, which I'm not concerned with. Instead, I want to go to the right side. So if I select my right outside shoulder, I can continue to keep the default values, apply, and then close. Notice now we have additional control lines. And these control lines control the shoulders based on the rollover values provided. If I hit Process Ahead, you will now see that the entire template is showing super elevation rates, and we are meeting the rollover criteria that I assigned in the Apply Shoulder Rollover Lock command. Now I'm going to show you how to import super from a previous version. This particular project was done in prior to version 8.7 and had super elevation. And so all I need to do to import the super elevation from an alignment is to right click and say Import Super Elevation from Alignment. Notice it says Successful Completion. Dismiss the dialog. And we have super elevation control lines that have been imported from the previous version. Note that it's not super elevating. That is because when you import from a previous version, you will need to manually assign the point controls. So I'm going to select Point Controls, select the type of point control I want. It's vertical. It is super elevation. We select the super elevation we want. First we're going to select the point we want to super elevate. And we're going to select the super elevation line that we want to use. And that would be ramp B right. And we have to provide a reference or pivot point. And we add that point control. Notice now the lane is super elevating. And as I manually process through some stations, you can see it's super elevating. I'm going to close the roadway designer at this point, and I'm going to take you to a different data set for 4-lane. I'll immediately go in and access the roadway designer, and I'll show you how to super elevate a 4-lane section. Notice this is a 4-lane divided, and what I want to do is I am going to initially have a planar super elevation, or a zero super elevation across the median, and super elevate the left and right roadway. And then I'm going to apply super elevation to the median to show you how that works. Well, in order to do this and to easily facilitate this process, I'm going to access the templates command, and I'm going to swap my template, my standard divided template, with one that has a median plane component that connects the inside edges of pavement. Now note the difference in my cross-sectional view. You'll see that I have a median plane component that I'm using to help visualize the super elevation, and also to provide access to the point, the pivot point in the center of the median that represents the profile grade point. Once again, to access Super Elevation Wizard, I'm going to right-click within the Super Elevation diagram window, go to the Create Super Elevation Wizard, and I'm going to use the table method. I'm going to browse to the correct .sup file, and notice this .sup file has 70 miles per hour 4-6-lane divided .sup. For those of you who don't already know this, the super elevation file has always been just a 2-column based ASCII file. So you have values for 2-lane or 4-lane, it could be 3-lane or 5-lane, and in this instance I created a custom file for 4-lane values and 6-lane values. I'm going to select percent of total on tangent. I want it to be 80%, and the links are the total transition. Now I'll click Next and add my first section. To super elevate a 4-lane divided highway, it is necessary to enter more than one section. I'm going to super elevate the left side, so I will key in a name called left. I will identify the crown point, left crown line, the left range point for the left section, and the right range point for the section. At this point, this is critical, the pivot direction. I want to pivot about the right edge. I'm going to leave it as number of lanes as 2 because I want it to read from the first column of that .sup file. I'm going to hit OK, and I've added my left section. Now I want to add my right section. Go back to the Add button, key in a name of right, provide a crown point for the right side, the left range point for the right side, the right range point for the right side, and the pivot direction for the right side is the left edge of pavement. Select OK. Next. And notice now my section combination box contains both a left and right section. So I can provide a different initial slope than the one that has been computed from the template. Select Finish, and I have my super elevation for my 4-lane. Also notice that my median plane is still at 0%. Let us go in and super elevate that median plane. Go back to the table method. Continue to have the same values that I had previously. Select Next within my wizard, and I'm going to add my median section super elevation. I'll provide a name, my crown point, my left range point, and my right range point, and at this point I want it to pivot about the center line. So I'm going to leave my pivot direction as from crown point. Select OK, Next, and Finish. Now notice I have super elevation all the way across the median that has the same rates as the pavement. If I swap back to my cross-section view, you will see that I have my median plane component. Well, to get rid of that, I'll go back to my typical sections, select the one with the median plane, swap it back to just the standard 4-lane divided, dismiss the dialog, and my median plane is gone. Also notice that within this particular data set that my median slopes are held to a slope-slope intersect, so the bottom of the ditch is floating and holding a standard set of slopes within the median. Also, I would like you to notice that within a super elevated area, for instance, in this area I have a full super elevation of approximately 5%. Notice that my shoulder is meeting a rollover value of 0.07, and I have not run the Apply Shoulder Rollover Locks command. How did I achieve this? Well, rollover locks can be achieved not only through the super elevation wizard and the super elevation view within the designer, but they can also automatically be applied within the typical section. So if I go back to my template drops dialog, select the template that I'm using, and select Edit, you will notice let me window in on the shoulder view. You will notice that if I select my shoulder point, it is constrained by slope to the right outside edge of pavement, but I also have the rollover values option toggled on. If I select the rollover values option, you will see that I can define within the template a high side difference and a low side difference and a reference point. And the reference point means that from the right crown line to the right outside edge of pavement, the high side difference between that slope and the slope to the right outside shoulder will be 7%, and on the low side it will be 0%. So for those of you who want that particular functionality, that's how you would access it. I'm going to cancel the Create Template dialog and close the Template Drops dialog. I'm going to back to the Display Superelevation view, and I'm going to review with you for a moment the Curve Set Editor. So for those of you who are wanting to edit your curves within your superelevation dialog, you have a number of methods to achieve this. You can physically go in and move points. I'm going to let my WebEx catch up so you can see where we are, and key in a station and cross slope value. You can set dynamic locks, which are similar to the locks within the geometry commands, so it steps to particular stations and particular cross slopes. Or if you're more comfortable, you can use the Edit Curve Set Stations command within the super diagram. To access the Edit Curve Set Stations command for a particular curve, place your cursor within the curve set you would like to edit, right-click, and select the Edit Curve Set Stations. This is the Curve Set Station Editor. Notice how it automatically put me on Curve Set 2. That is where I right-clicked. I can scroll back and forth between different curve sets. I can provide curve set information if I have a calculator or a spreadsheet and I'm wanting to enter information so I don't have to go back to geometry and do review geometry to have those key point information. And I can go in and I can key in the values I prefer. For example, if I want it to be 6%, I can key in 6%. If I want to key in a different station value, I can key in a station value. And I can apply that edit. And when I apply that edit, it will automatically go in and update the child control lines of the primary controlling line. Those of you who have attended any other lectures regarding point constraints and point controls within the Create Template command will be aware that there are various methods of constraining points within InRoads 8.7 within not only the template, but you can also constrain them within the superelevation diagram. What does this mean? This means I can constrain a point to be held along a slope, or I can constrain a point horizontally or vertically, or I can even constrain a point to use mirror cross slope. That is how we achieve the high side and low side supers. All we would want to do is we would have a point and constrain a second point to mirror that cross slope. Notice that I have constrained checkboxes. These constrained checkboxes reflect the fact that the reverse crown and the full super outgoing and reverse crown are constrained to the parent full super point. Now let's say for the sake of discussion you would like to add additional points to this grid control view. You can see that we can go in and add as many points as we want and edit those points as needed. One final issue I'd like to discuss that is not within your agenda that we were going to cover today is the fact that we can still import superelevation from ASCII. So those of you who want to import your superelevation from an ASCII file, it's going to use the same file format as previous versions, except for the fact that we only use the station and cross slope values. So you do not have to use inside rollover, outside rollover, planar, non-planar, and all that's covered in the help from previous versions and has been carried forward to this particular version, even though we don't use all those values from the ASCII files from superelevation. But that file is a pipe delimited file, and the format is documented within the product. And I want to give you in summary that this InRoads Group 2004 edition, version 8.7, provides the most capabilities for superelevation to date. And using a wizard method of superelevation, the process is automated and fully adaptable to any design situation. Because the interface utilizes a super diagram approach, editing and visualizing is easy and understandable. This concludes our lecture for today on InRoads version 8.7 superelevation.